we're going to take this idea of limits that we've been talking about so far and extend it a little bit and talk about limits at infinity. So first, let's talk about what at infinity means in terms of limits. This term at infinity is kind of a weird mathematical phrase. We can't actually be at infinity because infinity is essentially the idea of a number that's increasing without bounds. So it gets bigger and bigger and bigger. So we usually think of infinity as a really big number, but it's not actually a number. It's the idea that the number is getting bigger without bound. So if we take this formal definition of the limit from section 1.2 and modify it a little bit, we're going to be looking at what happens to a function instead of as x approaches some number c. We're going to look at what happens as x increases without bound. So this phrase without bound is the idea of infinity, where x is just getting really big. What happens when we plug bigger and bigger and bigger numbers in for x? So the limit is a real number r. If we can make f of x arbitrarily close to r by, instead of taking x sufficiently close to c, since we're not approaching some particular value c, we're going to make x really big. So by making x sufficiently large, could have left sufficiently in there, I guess. Okay, so instead of picking values closer and closer to some value c, we're just making x really big. And I should probably say making to get the grammar right there. And then also, since x is getting really big, it's not approaching some value c, so we don't want to say not equal to c. We can't be equal to infinity, so we can take that part out of the limit for this extension of it. So if that limit exists and it's a real number, then the notation we're going to use is x, the limit as x approaches infinity of f of x equals r. Or we might say, instead of infinity, we might say negative infinity, because we could be looking at values of x that are getting really big, but in the negative direction. So let's look at what that would mean as far as a graph goes. So we've got the function 1 over x here. It's a function that we should be a little bit familiar with. And the idea here is when we take this limit as x approaches infinity of f of x, what we're looking at here is what happens when we move along the x-axis going to the right. And when we do that and we plug in bigger and bigger values for x, then what's happening is we're taking 1 divided by bigger and bigger values in our function here. And as you know, we plug in bigger values for x, 1 divided by a bigger number is going to be a smaller number. This function is never actually going to equal 0, but we can make the function really close to 0. Say we want it within 1/1000th. So 1/1000th of 0 would be 0.001. Well, we can do that by plugging x equals 1,000 in there. And then 1 over x is going to be 0.001. If we want f of x to be within 1/1,000,000th of 0, we can plug in 1,000,000. And any number bigger than 1,000,000 that we plug in is also going to give us something within that. So this limit here is going to equal 0 because we can get really close to 0 by plugging in big numbers for x. All right, so arbitrarily close to 0 by plugging sufficiently large values of x in. And the same thing's going to happen as we go to the left. So this limit right here, probably should have flipped these, is going to be what happens when we plug in large negative numbers. And if we plug in a large negative number, let's say negative 1,000, we would get negative 1/1000th. So if we want values within 1/1000th of 0, then we could plug in numbers bigger than negative 1,000. So this is also approaching 0. I do want to point out that these are positive values close to 0 as x is getting really big, and these are negative values close to 0 as x is getting really big but negative, but they're both approaching 0. We're not going to use a two-sided limit notation here. We can't approach infinity from both sides. So just looking at what happens as x gets big in the positive direction and x gets really big in the negative direction.